Hi, welcome to my video on equivalent fractions. Two fractions are equivalent if they represent the same number. Let's look at these three rectangles, which are the rectangles A, B, and C are identical. Let's divide them into different sections. Right here. Divide this one into 4 pieces, and I divide this one into 8 sections. Notice if I take rectangle A, it's the same rectangle, but I'm talking about, let's shade in 1 out of 2. And in the B, let's shade 2 out of 4. And in C, let's shade in 4 parts to 8 out of 8. So 1 out of 2 would be a fraction of a half. 2 out of 4 would be a fraction of 2 over 4. And 4 out of 8 would be a fraction of 4 over 8. Notice that these are identical, so this one piece is equivalent to 2 of these, is equivalent to the 4 of these. So notice that they're equivalent. So the fractions a half, 2 quarters, and 4/8 are equivalent fractions. Also note a half and 2 over 4 as a fraction is really 1 times 2 over 2 times 2. And 4 out of 8 is the same as 1 times 2 over 2. 1 times 4 over 2 times 4. Showing you this, the equivalency, is going to take me through the concept of equivalent fractions, reducing, etc. For any fractions a over b, where a and b are natural numbers, we're not entertaining b as 0 denominator. If the numerator and denominators are multiplied by the same natural number c, equivalent fractions are formed, like up here. So if you take 1 over 2 and multiply by 2 over 2, you get 2 quarters. If you take 1 over 2 and multiply by 4 over 4, you get 4 over 8. So all three of these are equivalent. So let's look down below and take a over b and multiply it by c over c. So we get ac over bc. This is another way to write down multiplication. So if I take 1/3 and multiply by c, so 1 over 3 multiplied by 2 is my natural number, I'll get 2 over 6. If I take 4 over 5 and multiply top and bottom by 3, so 4 over 5 times 3 times 3, I'll get 12 over 15. And if I take 7 over 6 and multiply it by 7 and 7, I get 49 over 42. So multiplying a fraction, the numerator and denominator, top and bottom, by the same number will give you an equivalent fraction. Practice. You practice. When you see the word practice in any of my videos, it means you work them out, pause, work them out, press play, and see if you're right. So 2/5 multiplied by 6 on top and bottom will give me 12 over 30. 3/8 multiplied by 5 and 5 on top and bottom gives me 15 over 40. And 7 over 10 multiplied by 8 and 8 top and bottom, 7/8 are 56. 10 times 8 is 80. And 5 over 3 multiplied by 10 on top and bottom will give me 50 over 30. So notice multiplying the top and the bottom of a fraction by the same number gets you an equivalent fraction. Let's try it and fill in it another way. Fill in the numerator such that the fractions are equivalent. So if I have a 1/2, 1 over 2, and I have a 6 on the bottom, that means the 2 was multiplied by the 3. So that means I got to multiply the top by 3. So 3 ones is 3. So 1/2 is the same as 3 over 6. If I have a 5 and a 10, 5 must have been multiplied by 2. And so I have to multiply the 8 by 2. So 2 times 5 is 10. 2 times 8 is 16. 7 times what number gives you 28? So the answer is 4. So I multiply the top by 4. So 4 times 2 is 8. So 8 over 28 is the same as 2 over 7. 10 times what number gives you 50? And you say 5. So you multiply it by a 5. Top and bottom. So 5 7s are 35. And 6 times what number gives you 18? You say 3. So you multiply the top by 3. So 3 5s are 15. 3 5s are 15. 3 6s are 18. So everything is... What number multiplied by 4 gives you 16? The answer is 4. So we multiply the top by 4 to make it equivalent. So 4 times 3 is 12. Practice. You work out these. Pause. Play it back. 3 times 2 makes 6. So we multiply the top by 2. 7 times 3 gives you 21. So 3 times 2 is 6. 5 times what number gives you 25? 5. So the top is multiplied by 5. 4 5s are 20, or 5 4s is 20. 6 times what number gives you 60? The answer is 10. So we multiply the top by 10. So 5 10s are 50. 4 times 7 is 28. So we multiply the top by 7 to keep it equivalent. 7 times 1 is 7. 8 times 2 is 16. So we multiply the top by 2 to get 6. 6 over 16 is equivalent to 3 over 8. So notice, make them balance. Multiply the top and bottom by the same number. Now let's reverse it. Fill in the denominators such that the fractions are equivalent. So now I have it reversed. So we multiply the top by 4, we'll get 4. So we multiply the bottom by 4, and we get a 20. 3 was multiplied by 2 to get 6, so I multiply 8 by 2 to get 16. 2 was multiplied by 3 to get 6, so I multiply the bottom by 3 to get 18. 4 was multiplied by 5 to get 20, so 5 times 7 is 35. 1 was multiplied by 7 to give you the 7, so 7 times 2 is 14. 3 was multiplied by 10 to give you 30, so we multiply the bottom number by 10 to get 40. Practice, pause, work with your answers, play it back. 3 times 2 gives you 6, so we multiply the bottom by 3 to give you 33. 5 times 2 gives you 10, so we multiply the 12 by 2 to give you 24. To get 35, we multiply the 7 by 5, so we multiply the 4 by 5 to give you 20. 5 into 20 goes 4, so 4 times 5 is 20, so 4 times 8 gives you 32. 1 times 6 gives you 6, so 6 times 6 gives you 36. Again, multiply the top and the bottom by the same number because equivalent fractions. 7 and 6 into 42 goes 7. So 7 on the bottom also. So that gives you 5 7s is 35. Just working on equivalent fractions. Equivalent fractions are formed by dividing the numerator and denominator by the same number. So just then we multiply them by the same. Now we can do the reverse. This is the same as simplifying a fraction or reducing to lowest terms or form. So when you hear somebody say always reduce fractions, that means simplify it in math. Reduce to lowest terms all means the same thing. So in order to reduce 4 over 10, we look for the GCF. Look for 4. Is there a 4 and 10? No, but they're even. So the GCF of 4 and 10 is 2. Let's divide the numerator and the denominator by 2. 4 divided by 2 is 2. 10 divided by 2 is 5. So 4 over 10 is the same as 2 over 5. Between 3 and 21, 3 is the smallest number. 3 is a factor of 21, so the GCF is 3. So let's divide the top and the bottom by the same number. Again, reversing what we just did. 3 divided by 3 is 1. 3 into 21 goes 7. GCF of 14 and 35. We look at the smallest number, 14. 14 is not a multiple or factor of 35. We try 7. 7 is the GCF. 7 goes into 35 5 times. So we divide the top by 7 and the bottom by 7. 14 divided by 7 is 2. 35 divided by 7 is 5. 15 and 25, I see a 5 as the GCF. 5 is a common factor. 15 divided by 5. 25 divided by 5. 15 divided by 5 is 3. 25 divided by 5 is 5. What numbers? What's the GCF here? I see repeating digits 2, repeating digits 3. That means I know that 2 into 22 goes 11. So 11 is your GCF. So 22 divided by 11, 33 divided by 11 gives me a 2 over 3. So notice you're breaking it down. We're looking for the GCF. GCF is so important. If the GCF has 2 or more factors, division can be done by 2 or more times. Let me explain. If I have 12 and 18, I can divide by 2 because they're even. That gives me 6 and 9 when I divide. Now I notice that I have a 3 as a common factor, so I can divide by 3. 6 divided by 3 is 2. 3 divided by 3 is 9 divided by 3 is 3. So if I don't see the GCF, the biggest, or the GCF right away, I can divide by one factor and then another. Sometimes you don't always see it. Like 30 over 60. I can cancel my zeros and I get 3 over 6. But I see 10 as that's the same thing as dividing by 10. So if I scratch those 2 zeros there, I'll automatically get 3 over 6. But if you just want to work it this way, you don't have to. You can scratch right away. I got 3 over 6. And what do I see? I see 3 common to both of those. So I divide by 3, and I get 1 over 2. As you can see, 30 is a half of 60. 1. You could have. Let's go down below and I'll explain it again. What about if you see that there's a 6 common? Same 12 over 18 was a 2 and then a 3. So if you see that 6 is your GCF right away, then you'll get to 2 over 3. Finding the GCF will get you there faster. 30 and 60. If you divide by 30, which is your GCF, it'll give you a 1 and a 2. But you don't have GCF, yes, but if you break it down into one factor, then another, it still works. Notice, if possible, always simplify reduced fractions to the lowest terms. You always reduce your fractions to lowest term in math. Always, always, always. Very important. Let's continue. Practice. Pause. Work these out. Down here. Pause and work these out. And when I get down here, this is all for a student to do ahead of time. Reduce these. I see 2 as a GCF. So I'll divide by 2. Now, I don't have to write it down all the time. 2 into 6 goes 3. 2 into 14 goes 7. So if you see the 2, you can do it in your head. You don't have to. What's the GCF of 10 and 15? I see a 5. So I divide 5 into 10 goes 2. 5 into 15 goes 3. If you wanted to, you could say 10 is 10 divided by 5 and 15 divided by 5. And that'll give you 2 and 3. But notice this takes a little bit longer. Once you're familiar with it, then shorten it up. 11 is the GCF. The only factor of 11 is 11 because it's prime. So 11 is 4 into 44 is 11. So 11 divided by 11 is 1. 11 divided into 44 is 4. 14 and 21. Common factor. They're not even. Try a 7. Oh, 7. 7 into 14 divided by 7 is 2. 14 divided by 21 is 3. Shorten it up when you know that you're going to reduce fractions. 9 is not a factor of 30, but 3 is. 9 divided by 3 is 3. 30 divided by 3 is 10. Again, we're dividing top and bottom by 3. 2, let's pretend that they're even and we see 2. So 2 into 8 goes 4. 2 into 8 goes 14. But you notice they're still even. Let's divide by 2 again. So 2 into 4 goes 2. 2 into 14 goes 7. If you've seen that 4 was a GCF, you could have divided by 4 right away. 8 divided by 4 is 2. 28 divided by 4 is 7. So 2 twice or divide by 4 once. But just keep going down. If you simplify 3 over 12, 3 divided into 3 goes once. 3 into 12 goes 4. Notice if you multiply the top and the bottom here by 3, you get 3 over 12. So we're breaking it down, reducing. Notice that 8 is a GCF of 2 of these. 8 divided by 8 is 1. 8 into 16 goes 2. We could have went with a 2. 2 into 8 is 4. 2 into 16 is 8. 2 into 4 goes 2. 2 into 8 goes 4. 2 into 2 goes 1. 2 into 4 goes 2. So this is divided by 2 3 times. But if you see 8 right away, it's quicker. 5 is a GCF of 10 and 25. Because they're ends and zeros and 5s, 5. 10 divided by 5 is 2. 25 divided by 5 is 5. 75. See a 5 again, because there's a 5 and a 0. 5 into 75 goes 15. 5 into 100 goes 20. And I see 15 and 20. I see a 5 again. 5 into 15 goes 3. 5 into 20 goes 4. If you had seen 25 right away and divided, you would have got a 3 and a 4. So if I divide by 5 and then 5 again, or if I divide by 25 right away. So if I get the GCF, it's faster. If I don't, I can still keep breaking it down. A factor of 12 is a factor of 42. Let's go with a 2. 12 divided by 2 is 6. 42 divided by 2 is 21. I got a 6 and a 21. I see a 3. 3 into 6 goes 2. 3 and 21 goes 7. I could have done 6 right away. This is your choice. Right here, reduce this, scratch the zeros, because I'm dividing by 10. 2 divided by 2 is 1. 2 divided into 6 is 3. Notice if you have 100 over 100 over 400, you can scratch that because you're dividing by 10. You can scratch those two because you're dividing by another 10. Or you could divide by 100. If you divide both of them by 100, the same as scratching the 2 zeros. You get 1/4. Another question. Circle the fractions in column B, which are equivalent to the fractions in column A. So the best way to do this one is to go over here and reduce these down to see if you get 2/3. So 4 over 6, 2 is the common factor. So divide by 2, you get 2 over 3. Yes. 6 over 12, 6 is the GCF. So I divide by 6, I get 1 over 2. No. 20 over 30, I scratch the zeros, I get a 2/3. Yes. 8 over 14, 2 is, GCF is 2, so it's a 4 over 7. The answer is no. So those are the only two fractions equivalent to 2/3. Which ones over here are equivalent to 1/4? 3/8, can't reduce at all. 4 over 16, 4 into 4 goes once, 4 into 16 goes 4. Equivalent. 5 over 20, 5 is the GCF, 5 into 5 goes once, 5 into 20 goes 4. 9 over 36, let's see, 9 goes into 9 once, 9 goes into 36 4, so that one is also equivalent to 1/4. 4/5, 8 over 15 can't reduce. 8 is even, 15 is not even. No other factors of 8, only even numbers. 16 over 20. 16 divided by 4. 20 divided by 4 is 5, so that's equivalent. 40 over 45. We have to divide, 5 is the GCF, so I get it 5, 40 divided by 5 is 8, 45 divided by 5 is 9. No. 12 over 15, let's see, 3 into 12 goes 4, 3 into 15 goes 5. 3 is the GCF, so that's equivalent. And 8 over 15 can't reduce. That brings us to the end of equivalent fractions. I hope my video helped you. And if you like my video, press on the like button, the subscribe button, the notification bell, and if you wish, write a comment on my video. And also, remind everybody that I have a website, www.mathfullyexplained.com. Information about me, my degrees, teaching experience. Second section has teaching strategies used in my videos. The third section is on content, which gives you the topics, the number of videos of each topic. The topics I have completed will be in black font. The topics that I'm going to complete in the near future will be in red font. Thank you very much. Bye.